All right, how we doing, guys? Continuing to take your questions on 9-7. And again, these are not a problem for me to look at all. So quit asking for or quit apologizing for asking me to do these things. So let's take a look at 46. Okay, these were one of the two-story problems at the end. We're going to take a look at 48 here. I'll shoot another video for that one here in just a little bit. Says, while standing on a ladder, you drop a paintbrush from a height of 25 feet. After how many seconds does the paintbrush land on the ground? Now, let me just point out one thing on this. Like I said, I don't mind doing these, but I don't know. I just want to point this out, see if you guys caught it or not. If you get in your textbook um, and look right to the left of number 46, says example 6 on page 602. And so, while I didn't cover these in class. As you look back through your textbook, sometimes they give you some problems that might be similar to these, and maybe those might be of help to you. I just don't want you to sit and struggle with these, waiting to hear back from me and for me to shoot this video. So, take a look at those notes along the side. Take a look at some of the other examples in the textbook. Hopefully, you took a textbook home with you. So, all right, so let's take a look here. This is actually a vertical motion model problem. So I've got that equation written up there. I didn't even have to look it up. Hopefully, you guys don't now, because again, we've worked with this quite a bit. And so let's take a look at this. So I've got the vertical motion model up there. Let's fill in what we know. Again, t is going to be my variable, simply because that's what we're looking for. How long is it going to take it? So time is my variable. So that's the one thing I'm not going to fill in. I should be able to fill in values for the rest of this. So we're looking at, when is this thing going to hit the ground? All right, so the height that we're looking at is 0, negative 16t squared, plus, all right, v is the initial, excuse me, v is the initial velocity here. So this is a little bit different, simply because we're not, we've looked at this before where we were throwing it at a certain velocity, and it gave you that initial velocity. Here, we're holding this, paintbrush, and we're simply dropping it. Okay, and I lost my marker. That's all right. I got another one here. Okay, so if we're just dropping this marker, what's the initial velocity? Yeah, you're right, 0. All right, so the initial velocity is 0. So this, I'm going to write it in there. This becomes 0 times t. We'll talk about that here in just a little bit. And s is the initial height, all right, or the initial position of this. And we are standing at the top of a 25-foot ladder. Okay, so here's what I've got, all right. And really, I'm going to rewrite this a little bit, because 0 times t is always just 0, and adding 0 really doesn't do anything for us. So we get 0 equals negative 16t squared, plus 25. All right. So here's the equation that we want to work with. Now, at this point, we've got a couple options here. Again, I want to factor this thing. I've got it equal to 0. And I see the two terms. That makes me think a difference of two squares. But right now we've got an addition. We've got an addition problem instead of a subtraction problem. But I do notice that this is negative. Okay. So what I'm going to do is, since addition is commutative, I'm going to switch these two. All right. And I'm going to make it 0 equals 25. Now, I could put plus negative 16t squared, but I'm going to put minus 16t squared, just so it fits our pattern just a little bit better. Okay. And so again, catch what I just did. Since it's addition, addition's commutative, because again, it's a difference of two squares. All right. We'll talk about, I think maybe some of you are saying, hey, wait a minute, these are perfect squares, but it's an addition problem, not a subtraction problem. We need that to be a subtraction problem. But adding a negative, if I put plus negative 16, it's the same problem. So writing minus 16t squared helps us fit that pattern a little bit better. All right. And now, like I was talking about, we've got our subtraction problem. This is a perfect square. It's 5 times 5. This is a perfect square. It's 4t times 4t, not 4d, but 4t. All right. So now I should be able to factor that. I know I got my two sets of parentheses, and one is plus and one is minus, because that's my pattern for difference of two squares. 25 is 5 and 5. and 16t squared is 4t and 4t. And now I'm ready to use my zero product property. All right, I'm multiplying two things and getting 0. So 5 plus 4t has to be 0, or 5 minus 4t has to be 0. One of those two equations has to be true. And that's that zero product property. And I've got a couple two-step equations here. So I subtract 5 over here. I get 4t equals negative 5, and I divide by 4. I get t equals negative 1.25. Okay, we'll talk about that here in a little bit. Over here, I'm going to cha-ching this thing. Subtract 5 over here. I get negative 4t equals negative 5. And now I'm going to divide by negative 4. And a negative divided by a negative is a positive. I get 1.25, or 1 in 25 hundredths. Okay. And again, we've talked about this before. The negative here is a solution to this equation, but it doesn't make sense in our situation. We don't talk about negative time, although it does have some meaning. We might talk about that a little bit later. But this, we didn't do anything wrong. It just doesn't make sense in our situation. So the time that it's going to take it to hit the ground is 1.25 seconds. Okay. All right. So a couple things here. Catching that as the vertical motion model. Understanding that if we simply drop something, its initial velocity is 0. Okay. And then the other thing is using the commutative property to make this a difference of two squares rather than the sum of two things that are kind of perfect squares, even though that one's not. Okay. And then again, recognizing when you've got a solution to an equation that doesn't answer your problem, so you got to get rid of it and solving it from there. So, all right, again, this was 46 on 9-7. I hope that helps. Let me know if you have any other questions. Take care, guys.